appropriate to use tangent theta in getting the theta or the direction. So let's try to solve the theta or the direction of our vector. So we will use tangent theta is equals to opposite over adjacent, and then of course we're not going to look for the tangent theta. We are just going to look for the theta only. So we will transfer tangent to the other side. So this now becomes tangent to the power of -1, or we call that as arctan. So if it's cosine to the power of -1, that's arc cosine. If it's sine to the power of -1, that's arc sine. Okay, so arc represents the negative exponent of the different trigonometric functions. And then we'll just simply copy 3 kilometers over 5 kilometers, and then you have the answer. But how do you put arc tan in your calculator? Click shift and then tan. That's how you get arc tan. However, we're not yet done because we are to look for the direction. So how are we going to look for the direction? We have here, we will refer our direction to the position of theta. So notice that theta is located here, below east. So meaning the theta originates from east and then it moves to the south, meaning this is south of east. Okay, so how are you going to read this? This is south from east. So the initial point is east and then it moves downward, which is south. Okay, so south from east or south of east, that's the direction of the theta. So our final answer is 5.83 kilometers and then 30.96 degrees from our solution earlier, 30.96 south of east. Okay, so that's the complete answer, 30.96 degrees. Final answer is 5.83 kilometers, 30.96 degrees south of east. Okay, so these are the representation of the different directions. So para di mo maglibog class, kaning mga second nga direction mo ni ang origin nila or asa sila gikan. Notice, gikan siya sa north nya ni move siya sa west. Mao na siya. Okay, kani siya, this is north of east. So gikan siya sa east, ni move siya sa north. So nadira atong theta. Okay, another example kani, gikan siya sa east, ni move siya sa south, so we have south of east. Right, so that's how you read the directions. Okay. Next, so let's have this sample activity. So you already answered this one, but let's just check. So we have here a hiker that walks 2 kilometers south and 4 kilometers west. What is the sum of her distance traveled or the resultant vector? So we'll draw 2 kilometers south and then 4 kilometers west. So our resultant vector is here. So this is 2 km, this is 4 km. So let's just answer it directly. So we have RV is equals to square root of 2 square plus 4 square. So our resultant vector is, okay, I'll try to calculate. 2 square plus 4 square. So we have 4.47. Don't forget the unit. So that's 4.47 kilometers. Okay, now let's have the angle. So this is the Cartesian plane. So the theta is located here. So theta is equals to tangent, arctan rather, arctan, and then opposite, which is 4, and then adjacent is 2. So our theta is arctan 4 over, so 63.43 degrees. And the direction would be, so our theta originated from the south, so south, and then it moves to the west, so of west. So our final answer is 4.47 kilometers, 63.43 degrees west of south. Alright, so now let's have another example. Okay, let's draw. A hiker walks 1 kilometer west and then 2 kilometers south. So 1 km and then 2 km. So our resultant vector is here. RV is square root of 1 square plus 2 square. So our resultant vector is 2.24 kilometers. And let's draw our Cartesian plane. And our theta is located here. So theta is equal to tangent theta, arctan rather. Arctan opposite 2 over 1. So the answer is 63.43 degrees. And the direction would be, so from the west, it moves, okay, wait. So this is from the west of, okay, so south of west. Our final answer is 2.24 kilometers, 63.43 degrees south of west. So from the west, it moves to the south, or south from west. Okay, so that's how you try to add vectors using the Pythagorean theorem. Now, let's assume that you're here in this point. So again, you are in negative 6. So we will call the negative sides as the south and the positive sides, or the positive points, as the north. And you want to walk to SMC side. So let's just call the negative 6 is in Minglanilla. And then you want to go to SMC side. That's north. That's your destination. Okay, so what is your displacement rather? What's the displacement for that? You can just simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can count in order for you to actually get your displacement. But you can solve using a formula. So when we talk about displacement class, this is a change in position. So from Minglanilla and you go to SMC side, so there is a change in position. So when there is a change in position and it has a magnitude and direction, this is a displacement. Please take note that displacement has a magnitude and direction. So if it has a magnitude and direction, do you think it is a scalar quantity or a vector quantity? Okay? So, correct. This is a vector quantity. Displacement is a vector quantity because it has both magnitude and direction. So, in order for us to ideally get the displacement, so we will use this formula. We have delta D. So, triangle there is the Greek word for delta, which means change. Delta D is equal to D sub 2 minus D sub 1. So D1 is the initial point, D2 is the final point, and delta D is the change in displacement. So we will just simply use the formula in order for us to get the displacement, diba? Mas easy to use the formula than just manually counting the distances or the displacements. Okay, so let's have a sample problem. We have here to obtain the displacement of a jogger who started at 4 meters and ended at negative 3 meters. So, for example, naani siya sa Abellana. So, nag-start siya sa Abellana, then niadto siya sa, let's say, Bolacau, o, diba? Inanaing yang pag-jog. So, that's the destination of the jogger. So you can just simply count if you want. So from this point at positive 4, we have 1, 2, 3, 4, 5, 6, 7. So you can say that the jogger has a displacement of 7 meters towards south or going south. You can just do that. But what if the points are like 99 or like hundreds? You can't count. That's not practical. So that's why you're enrolled in this class, to make things easier. So that's why we have the formula. So our formula here is the delta D equals D2 minus D1. So our initial point is here, D1. And our final point is negative 3. So we have negative 3 minus positive 4. So rule of integers, negative 3 minus 4. So our displacement is negative 7 meters or 7 meters south. So let's have this different samples. We have it here. So obtain the displacements of the following change in position using the number line. Again, we will assume that the negative points are south and the positive points are north. So we have here negative 5 meters to positive 6. So this is our D1 and this is our D2. Okay, so the solution for that is, of course, here. So you have positive 6 minus negative 5. The rule of integers, 6 minus negative 5, this now becomes plus. Diba? So that's why we have positive 11 meters north. We have here, this is D1 initial point, D2 final point. Right? So the answer would be negative 6 minus negative 1. This becomes negative 6 plus 1. So of course, rule of integers, this becomes negative 5 meters or 5 meters south. Right? Third example, we have here D1, this is D2. Then you have here negative 7, that's D2, and positive 1. So negative 7 minus 1, that becomes negative 8 or 8 meters south. So this is D1, this is D2. So to simply get the displacement, let's just use the formula we have here. The negative 7 is the D2 and then minus 7. So negative 7 minus 7, that becomes negative 14 meters or 14 meters south. And last, we have here, this is D1, this is D2. So 3 meters north, so this is positive because we assume that north is positive. 9 meters south, so this is negative because we assume that south is negative. To solve, we have here negative 9 minus 3, Negative 9 minus 3, that becomes negative 12 or 12 meters south.